All right, so this video covers Appendix A, which deals with reading and working with graphs, which will be very important for this course. It's something that economists do frequently is visualize data and models in a graph form because it is easy to interpret and understand and obtain the information that it's trying to convey very quickly because it is visual. So the first thing to understand is the difference between independent variables and dependent variables. So the slides here say that an independent variable is a variable whose value is determined independently of or outside the equation under study. That's not necessarily that helpful. A better way that I like to think of it is that independent variables are the ones that cause something else to happen. So the one that is doing the causing is the independent variable, and it has an effect, which is the dependent variable. It affects some other value of interest, and that is the dependent variable. Now, the dependent variable, in my mind, it makes more sense because it's called dependent. It depends on something else. It's caused by something else, right? So that one's not too hard to remember. But sometimes the independent title of independent variable can be not as easy to understand, but just think of independent variables as the ones, the variable that is doing the causing of something else. Now, a quick example of two variables might be, let's see, height and weight. Here's a good one, height and weight. So take maybe a couple minutes, go ahead and pause the video. Think about which of those two, if they are related, which is independent and which is dependent. So the independent variable in that situation is height. Height is causing, to some degree, a person's weight. And if that wasn't obvious to you, hopefully you took a second and thought, well, which one causes which? Does a person's height generally determine their weight, or does a person's weight determine their height? And which one of those obviously isn't true? A person's weight does not determine someone's height. It's the other way around, right? Now, there are other things that determine weight other than height, but it is a contributing factor. So height, in that case, is the independent variable, and the dependent variable is weight. A person's weight, to some degree, depends on their height. Okay, so there you go. Dependent variable is weight. The independent variable is height. Okay, now those two variables have what's called a direct relationship. A direct relationship basically means that the two variables move in the same direction. So as a person's height increases, generally so does their weight, at least on average. And so they move in the same direction. If you're shorter people weigh less, right? So that's a direct relationship because they move in the same direction. Taller people weigh more, right? So that's a positive direction. They're moving in the same direction. All right, so what does that look like in terms of a graph? All right, so height is our independent variable, so it goes on the x-axis. And weight is the dependent variable, so it's on the y-axis. Okay, and like we said, they generally move in the same direction. So if we had some data, some empirical observations, and we put them in this two-dimensional space here, we would see something, that might look like this, right? When these are data points, so each individual person is a data point. All right, so here are people that are short and lightweight, and here are people that are taller and lightweight. We might have some outliers here, right? But for the most part, if we put an approximate line through these data points and we graph that line, it's basically going to be a positively sloped line. So this is what a direct relationship looks like on a graph, and this might be something we would see if we plotted height versus weight for different data points. Now, the other type of relationship, inverse, just means, again, that they move in opposite directions. And so for that might be something like MPG versus speed in miles per hour. Okay, for a vehicle, right? So go ahead and pause this for a second if you need to. Think about which one depends on the other, which one causes the other, and let me know where you think I should put them on this graph here. All right, so hopefully you came to the conclusion that speed determines gas mileage in terms of miles per gallon, or how far someone can travel for every gallon of gasoline, right, per gallon of gas. And yeah, there's a causal relationship here. The faster you go in general, and maybe you didn't know this about cars, and that's fine, but the faster you go in general, the worse your gas mileage is. So you get worse fuel economy, worse gas mileage. You can go fewer miles per gallon of gas the faster you go. Now, that's not a strict relationship, but that is the average relationship between these two things. And that's an inverse relationship, right? As you go faster, as your speed increases, your mileage per gallon decreases, right? So they move in opposite directions. And of course, if we got some data points from some sort of experiment, right? Whoops. Ignore those down there. Those are outliers now. It might look something like this, right? Here's the relationship, some outliers. Okay, and we said that speed causes miles per gallon, so speed is on the x-axis, measured in miles per hour. And this is fuel economy, miles per gallon. So fuel economy in miles per gallon, right? And if we draw an approximate line through those data points, it's a downward sloping line, right? So there's an inverse relationship graphically. All right. So let's take a look at some actual data, perhaps. Here we got miles per hour and miles per gallon. So there's our speed and our fuel economy. And as you can see, for increasing speeds, for higher speeds, the miles per gallon goes down, right? So there's your inverse relationship. One goes up, the other goes down. Miles per hour increases as you go down the table. Miles per gallon decreases as you go down the table. They move in opposite directions. So here's that data in a table, which is great, but honestly, the visual representation in the graph conveys the same information, basically, but visually, so it's conveyed more quickly. It probably took you a few seconds to process that one was going up and the other was going down, right? So, but that's pretty obvious and clear in the visual representation here. Okay, so visually again, we see that direct relationships have a positive slope and inverse relationships have a negative slope like the one I've drawn here. Okay. Now, as far as constructing a graph like this, you're basically just using two number lines, and we're actually just using part of a number line. If we were to extend this in the other direction that it does travel that we're kind of ignoring, right, it does go in the other direction, and same thing with the y-axis here, right? So we're ignoring basically these quadrants here when we just look at this graph like that and isolate it. But that's actually what we're going to do in most of our economics graphs that we do. So just be aware of that. Okay. Let's see. Now the origin. The other thing to point out here is the origin is, of course, where both number lines cross, and that's also 0 on both of these number lines. So the origin is 0, 0, right? The point 0, 0. That's the origin. So let me show you that real quick, right? So origin, of course, right here. And it's where both of these number lines cross the x-axis, right? Remember that this is the x-axis. And this over here is the y-axis. Those are just number lines. They cross, both of them cross right where they both equal 0, right? So if we were to look at an isolated number line, of course, the x-axis is a horizontal number line. There's 0. Over here we have negative numbers. Over here we have positive numbers. Getting bigger, and here we've got infinity, and over here we've got negative infinity at the extreme ends. All right, so that's basically a number line in the x-axis format. We can also make it vertical. All right, in which case the lowest point is negative infinity. The highest point is on the number line is positive infinity. And right in the middle is 0, right? So and then we put these two things together, connect 0, 0, and that's where the origin is coming from, right? So there you go. Okay. That wasn't supposed to happen. All right, so again, here's a horizontal number line, for example. And here's a vertical number line. We're just putting those together to get to our graph, right? So easy peasy. There's the origin where they're both 0. And this point here, point A, if I wanted to label it, its coordinates, right, would be 1, 10. Okay. So, oh, I'm sorry, I got that wrong actually. So this, as far as coordinates go, the first number is the x coordinate and the second number is the y coordinate. So actually it should be 10 and 1. Okay, so point A is at 10, 1. Let me just make this more legible here. 10, 1. Because the x value is 10 and the y value is 1. Okay. All right, so here's another table, a table of t-shirts purchased. So we've got the price of shirts in the left column and the number of t-shirts purchased per week in the right column. So that's the quantity, in other words, of the t-shirts purchased per week. We, take a second and if you need to, pause the video and determine what kind of relationship. Is this a positive relationship, or is this an inverse relationship? I'm sorry, direct relationship or inverse relationship? Which is it? Do these things move in the same direction? Is it direct? Or do these things move in opposite directions and it's an indirect relationship? Which of those is it? Hopefully it didn't take you too long to determine which is which. Now, the second thing to do is determine which is the independent variable and which is the dependent variable. Which one causes the other? So hopefully you thought, well, it makes most sense, I think, for the price of t-shirts to determine how many are purchased. The quantity purchased, right? So it seems that price is the independent variable and quantity of t-shirts purchased is the dependent variable. And that's probably the best answer. Although I might talk about an instance where it might make sense to be the other way around, at least if you're in the micro course, the microeconomics course. But that's for a later day. All right, so there we go. We've got an indirect relationship. And as one goes down, the other goes up. So they're moving in opposite directions. And then the price is independent, the independent variable, and quantity of t-shirts purchased is the dependent variable. All right, so here we go. If we plot these points from our table on the graph, right, we can verify that each of these is correct. Here we've got point I right here, which is x equals 20, y equals 10. So, of course, we can verify on the x-axis that dot I lines up with 20 on the x-axis and with 10 on the y-axis. So there we go. That's coordinate I. We do that for the rest of these, j through n. And we've got these points on the graph, which, of course, look like they make a line, right? Of course they do. Yes, that's exactly right. So that's the nature of the transition between table data and graphical data, okay, is right there. We took our our table, and we plotted the points in our table. So that's our data. We plot those points in the graph in a coordinate plane, as it's called, right? This is a coordinate plane, x and y coordinates. And we get our downward sloping relationship there, our inverse relationship. Here's another example of a positively sloped curve and some data. So very similarly, price per pair of shoes and pairs of shoes offered per week by sellers. So offered by sellers. So the previous slide we saw purchased, right, or bought. So what we were really talking about back here, let me go back, right? This is a demand curve, as it turns out, okay? So the relationship between price and quantity demanded. So this is a demand curve. And as it turns out, this is a supply curve. So price, again, on the y-axis, but this time instead of an item purchased, we have items offered. So this is basically the supply side of the equation, businesses, right? And same thing, we've got some data points, and we can plot them on the graph, and when we connect them, it basically creates a line. So that's a direct relationship there, with a positive slope. Now, hopefully you've learned how to calculate slope. It's the change in the y value divided by the change in the x value. So if you take 2 points on a line and find how the y value changes and divide it by how the x value changes between those 2 points, that's the slope. It's also known as the incline of the curve. And a useful way to remember how to calculate it is that it's rise over run, right? So rise can be positive if you're going up. It can be negative if you're going down. So that's the rise is the horizontal change, the vertical change, or the change in the y value. And then the run is in the horizontal direction. So just like you run along the ground horizontally, right? That's the run. So in this direction, it's getting a positive run. We're going in the positive direction. If we're going in this direction, it's a negative run. So a little harder to maybe remember there. But graphically, I'll just show you. So here we have our x-axis, our y-axis. have 2 points on the line. This is a positive run, and this is a positive rise. So we have a positive number because the rise here is positive divided by, let me not do that actually, a positive number divided by a positive number. Both of these are positive. All right, this is the change in y, and this is the change in x. So just so you know, this delta, this triangle, is the Greek letter delta, and it means change. So change in y divided by change in x. This is a positive change in x. This is a positive change in y. Positive number divided by a positive number. This will be a positive slope, right? So there you go. That's how you get slope. And then if I put numbers to these things, you could actually give me a number other than just tell me it's positive, right? So if this was 2 and this was x value 8, the change is 6, positive 6, if we're going from this point 1 to point 2. And then in going from point 1 to point 2, the rise, maybe this is 10 and this is 30. So the change is positive 20 in going from point 1 to point 2, right? Then we basically have 20, the change in the y-axis, divided by the change in the x-axis, which is positive 6. So we've got 10 divided by 3, which is roughly 3 point, what would that be? 3 repeating, yes. Okay, or 3 1/3. So there's the slope of that line there, if those are the points, right? 2, 10, and 6, 20. I'm sorry, 8 and 20. It's hard to see that 8 there. 8 and 20. Yeah, 8 and 30, I'm sorry. The difference is 20. Okay. So there you go. There's a visual representation of it. Again, the rise and run. The run moving to the right is a positive run. If it was in the other direction, it'd be a negative run. And then moving up is a positive rise. Moving down is a negative rise. There's a negatively sloped line. Okay, so again, moving down is a negative rise. And therefore, since the signs of these are different, right? One is a negative number, the rise is negative, but the run is positive in this case. We've got a negative slope, right? Because a negative number divided by a positive number gives you a negative number, or a positive number divided by a negative number, conversely, gives you a negative number as well. If there's a negative number there, in other words, if they move in opposite directions, right? Inverse relationship, negative slope. If they move in the same direction, you've got a positive slope. So that's interesting, right? Okay. Now here's a nonlinear curve. And so the slope of a nonlinear curve is just the slope of the line that's tangent to the point that you're interested in measuring the slope of. So you can see at point A, there's a high, very steep, high slope at point A, positive slope. B, there's still a positive slope, but it's a lower number. And then C, right at the top, the slope is 0, right? There's a horizontal line right at the slope. And then at point D, you basically have a negative slope, and the further you move to the right on the graph, the slope becomes increasingly negative, so a bigger negative number, right? But that's basically the nature of a nonlinear curve. Is it's a line or a curve that has a changing slope, right? Whereas a straight line is a curve that has a constant slope. The slope is not changing here, whereas here the slope is changing. All right, so that's the end of the chapter. If you have any questions, please feel free to email me or text me. I'll get back to you as soon as I can. I can probably respond quicker if you text me. So if your question or whatever is convenient to that, go ahead and do that. Otherwise, good luck on your homework, and I'll see you in the next video series from Module 2, Chapter 2.